Hey everyone, this is Mr. Tima, and welcome to our episode on inertia or Newton's first law of motion. We got quite a few little video clips in here, so we're going to play these and hope you enjoy it.
The story begins with inertia. Physics is about movement, how things move and why things move. Here is a very large thing. What do you notice about it? It's not moving. Go ahead and try and move it. You can't. It doesn't want to move. Is that because it's so large? Try and move a smaller thing then. Well, you managed to move that a little way, but it was a great effort. It was as if it still didn't want to move. Even tiny things are reluctant to move. Even a pebble takes some effort to shift. This is the first rule of physics. Things like to stay where they are. Unless there is some force to push or pull it, no object in the universe will start moving of its own accord. It's as if all objects were lazy. But why is physics about movement if nothing wants to move? The answer is that there are lots of things in the universe that pull or push on objects and force them to move, whether they want to or not. You force the pebble to move. And since things are lazy, you'd expect your pebble to try and stop moving as soon as possible, wouldn't you? Well, you'd be wrong. Strangely enough, although when the pebble was at rest, it wanted to stay at rest. Now that it's moving, it wants to keep on moving. In fact, it would like to keep on moving forever and ever. The only reason it slows down and eventually stops is because things in its path force it to stop. The resistance of the air, or a tree it bumps into, the roughness of the ground. But if there were no air or rough ground or trees to get in its way, if you were in outer space, for example, when you kicked your pebble, it really would go on moving forever and ever. It would never stop. So how can we say that objects are lazy? If the pebble's moving, it's not being lazy, is it? Yes, it is. It takes just as much effort to stop moving as to start moving. You get a feeling for this when you're ice skating. When there's hardly any resistance to your movement and it's easier to keep on gliding along than to stop. The same goes for the pebble. If nothing gets in its way, if nothing helps it to stop, it will have to make all the effort to stop by itself. And it's much too lazy to do that. We can now modify the first rule of physics from things like to stay where they are to things like to keep on doing what they're already doing. If a thing is at rest, it wants to stay at rest. If it is moving, it wants to keep on moving. In other words, there is lots and lots of laziness in the universe. Physicists have a special word for laziness. It comes from Latin, inertia.
So hopefully you enjoyed that. That's like a little Saturday morning cartoon actually in Canada. Um, and it's a cute little cartoon, but hopefully that helps you understand that inertia is just a Latin word that is lazy. So things like to keep on doing what they are already doing. So Newton's first law is actually the law of inertia. It is the tendency of an object to resist a change in motion. If moving, it stays moving. If stopped, it stays stopped, unless acted on by an unbalanced force. And we just talked about what forces were and what balanced and unbalanced were in the previous section. Remember, unbalanced means they're not equal. Something is greater. Either the push force is greater or the friction force is greater. So, a car should stay in motion once it starts in motion. The problem is friction opposes it. Think about that. If we didn't have any friction, your car would keep moving forever and ever and ever and ever once you got up to speed. The problem is that wouldn't be very safe. If your wheels weren't causing friction to keep you to the road, you might fly off into nowhere. Okay? So sometimes you might hear this law of inertia said, an object in motion will stay at motion, an object at rest will stay at rest unless acted on by an unbalanced force. That's what happens to our test tube guys. You've probably all done this before, where you hit something. Maybe as a kid, if you actually went out and played really hard, you might have fallen off something like this. Okay, I always think of like in the car, the mom seatbelt, where like if you see something, she slams on the brakes, she puts her arm out, like almost karate chops you. That whole arm seatbelt. Or if you've ever had something on the front seat of your car, like a casserole or some kind of food, and you had to stop suddenly, it'll go flying off. Okay, because an object in motion will stay in motion. Okay, you see this all the time with cars, and since most of you live in the city, you've seen many car wrecks and things like that. Don't worry, this guy doesn't hit his head. I always think he's going to hit his head every year. All right, but you can see that. I've actually seen this where a ladder flies off of a truck. Okay, all that good stuff. So, injury, inertia is what causes injury. In car crashes, you tend to remain in motion unless acted on by another force until you hit something that resists you. Hopefully, that's a seatbelt. But a lot of times, what actually kills you is not the wreck, it's the inertia, you flying out of the car, hitting something outside the car, or hitting the windshield of the car. Okay, so seatbelts prevent from being thrown from the car, provides an unbalanced force to stop that inertia. Okay, so how does it really work? Now, things are a little different now in newer cars. We've gone a lot more electronical with this, with some like a solenoid. All right, but the idea is, especially in older vehicles, there was a weight underneath your seat. Okay, and when the car slammed on its brakes, everything remained in motion. So this block would slide forward. When that block slid forward, this little, shall we say, cantilever kind of clicked back, which stopped that pulley. This is in the wall of your car. And then that thing like pinches your seatbelt. And that's why your seatbelt becomes really taut. And if you know this, you know the only way to get your seatbelt to kind of loosen up for you to lean forward again is usually the car has to start moving again, because then the block slides back, which releases this little locking cantilever and allows you to start moving this pulley again. Okay. Now, a lot of times there is literally a little solenoid, which is just a little cylinder with an air bubble in it, or a little itty bitty piece of wire or something. And the same principle. If this slides forward, it sends an electrical signal and then it locks your seatbelt. Same idea over and over again. But this is like the manual operation of it. So, got a couple clips of The Simpsons here to help you do this. Okay, so this is one where Homer dresses up as Krusty the Clown. Okay, and he's going to go too fast, and he's going to remain in motion here. So let's blow this one up. Here we go. See if you can find the two things that show an object in motion stays in motion. So there are two, okay? The first one is the tire shooting off. All right, the first one is the tire shooting off, and the second one. So here comes our tire, shoots off, and then here comes Homer outside of there. Boom, slows down a little bit because of the glass. All right, here's another one of Homer in space, and really want you to focus on him once he gets out of his seat.
Minutes till liftoff and counting.
Mission Control, this is Corvair. Launch sequence initiated. All systems go.
Are we there yet? I'm thirsty.
Mission Control, request permission to sedate cargo ahead of schedule.
Permission denied.
Payload checklist, IRS surveillance satellite.
Check.
Ant farm.
Check.
Children's letters to God.
Check.
3, 2, 1. Make rocket go now.
Go, Dad, go! How doth the hero strong and brave a celestial path in the heavens pave? Go, Dad, go.
Sir, the TV ratings for the launch are the highest in 10 years.
Yay! And how's this spacecraft doing?
I don't know. All this equipment is just used to measure TV ratings.
It's beautiful. It's the most awe-inspiring sight I have ever seen. Giver of life, mother of us all. Hey guys, look what I smuggled aboard.
Homer, no!
Huh? They'll clog the instruments!
Careful, they're ruffled.
I'll take care of this.
You fool! Now we may never know if ants can be trained to sort tiny screws in space.
So hopefully you enjoyed that. Again, Homer really focusing on the part where Homer tries to stop, but he can't. The only thing that stops him is the window. Okay, and that breaks open the ants or whatever. But again, that idea that he's trying to stop with his hands, but nothing he can push off of pushes back on him. So he can't really stop. So inertia, the first law of Newton's, the first of Newton's laws. Okay, everybody have a great day. Mr. Timatron out.